welcome to this explainer. Today, we're going to unpack the underlying architecture of Claude Code, and honestly, it's going to completely reshape how you view autonomous coding agents. Now, if you've been following the AI space, you already know things are moving at absolutely breakneck speed. But look, today, we are not just looking at another new model release. We're looking at a fundamental shift in how software engineering is actually performed. We are going to pull apart the engine, examine all the parts, and see exactly what makes this system tick.
Let's kick things off with a bit of a provocation. Are you still treating your AI like a glorified autocomplete? Or are you actually ready to supervise an autonomous execution engine? Because for years, we developers have been trained to use AI as this, super-powered typewriter. You start typing a function, it finishes it. You ask a question, it spits back a code snippet. But the architecture we're exploring today, it flips that entire concept on its head. As the source material really emphasizes, the era of writing code line by line is ending. Literally ending. We're rapidly transitioning to a totally new paradigm where you define the intent, you establish the boundaries, and then you evaluate the results. You're no longer the typist, right? You are the manager. The system plans the workflow, it executes the commands, and it observes the results. Your actual job is to guide the machine. So here's our roadmap for this explainer. First, the agentic shift. Second, inside the execution harness. Third, the dual memory architecture. Fourth, surviving context rot. And finally, mastering developer workflows. Let's dive in. Section 1, the agentic shift. Moving from typist to supervisor. All right, so we're exploring a massive architectural shift here, going from passive generation to active environment interaction. This isn't just about a model getting smarter, it's about a system gaining actual agency. Let's trace how we got here. Back in 2017, sequence modeling burst onto the scene with the transformer architecture, a real game changer. By 2020, systems like GPT-3 gave us that powerful generative autocomplete we all know. Then, around 2022, frameworks like React introduced interleaved reasoning, meaning models could think, act, and then think again. But present day, that brings us to something entirely different: local agentic execution. We've evolved from simple sequence modeling to a true embodied AI that lives right there on your local machine. It has access to your local files, it can execute shell commands, and it iteratively reasons, plans, and edits directly inside your development environment.
Moving on to Section 2, inside the execution harness. Now, what's really fascinating here is that the large language model itself is just a tiny reasoning component sitting inside this massive deterministic scaffolding. Most of the system's reliability, it doesn't actually come from the model's intelligence alone. It comes from the execution harness wrapping around it. The very heartbeat of this system is the agent loop. Instead of just producing isolated text outputs, probabilistic text is translated into concrete interleaved actions. Step 1, it reasons about the current state. Step 2, it acts by invoking a tool or editing a file. And Step 3, it observes the output, captures it, and feeds it right back into the context. This continuous loop, reasoning, acting, observing, is exactly what allows the agent to handle those really complex, multi-step debugging and refactoring tasks. But here's the thing. Models hallucinate. We all know that. So the execution harness acts as a strict bouncer. It intercepts the probabilistic guesses of the model and forces them into structural safety. Every single action is parsed via strict JSON schemas. There's a rigid permission enforcement system checking if an action is allowed, denied, or if it needs user approval. Observations are captured in strict sandboxes, and if an API fails, no problem. There's robust retry logic with exponential backoff. The harness essentially ensures that even if the AI suggests something completely off the rails, the system maintains total deterministic control. So the absolutely crucial point here is that this harness governs a registry of over 40 specialized tools. This is what gives the agent literal hands. The model isn't just generating text, it's actively selecting from tools that can read your files, write specific string replacements, run your test suites, or even search the web for missing documentation. It's doing the work. Okay, Section 3, the dual memory architecture. Claude Code doesn't just treat memory as some giant bucket of text. Instead, it uses a highly structured, dual-layer approach designed strictly for continuity and relevance. Unlike a standard chatbot that just kind of resets every time you clear the screen, Claude uses an ingenious subsystem called AutoDream. This prunes and merges its accumulated knowledge while you're away. Think of it like this. When you aren't actively using it, AutoDream spins up a background agent to consolidate your session histories. It works almost exactly like biological sleep. It isolates recent interactions,
distills recurring patterns, like, say, noticing your project always requires Redis for testing, and then prunes out the irrelevant noise, saving only the generalized, useful facts for the future.
Furthermore, the architecture deliberately chooses file-based Markdown over vector retrieval. Now, why is that? Well, because coding requires precise, inspectable facts. A vector database uses fuzzy semantic matches. If you ask a vector database for an auth routing convention, it might blend 3 different approaches together, which is a mess. But if you store memory in a plain Markdown file, the retrieval is lexical, it's deterministic, and most importantly, it's auditable. You can actually open the memory file, read it, version control it right there in Git, and edit the rules yourself.
So when you start a task, your initial session context is dynamically assembled. The system doesn't just hand the AI a blank slate. Oh no! It merges your explicit human instructions from local Markdown files. It adds Claude's historical auto-dream learnings. It injects live environment state, like your Git status and current directory, and then wraps the whole shebang in system scaffolding. It essentially builds a highly specific context window tailored exactly to where you are sitting in the codebase at that exact moment. Which brings us to Section 4, Surviving Context Route. Now, Claude boasts an astonishing 1 million token context window. To put that into perspective, this incredible capacity allows it to hold entire codebases in its working memory all at once. It takes in vast amounts of file data, documentation, and historical chat logs in a single breath. But there's a catch. This massive memory has a bit of a dark side. The exact same system that perfectly remembers your coding conventions can also remember your terrible abandoned ideas. As a session grows, the signal-to-noise ratio starts to drop. We call this context rot. Old stack traces, irrelevant shell outputs, abandoned implementation plans, they all silently pile up in the background. And because they're syntactically plausible, the model might start referencing a bug you literally fixed 20 minutes ago, silently degrading the agent's ability to reason cleanly about the current task. So this requires a massive behavioral shift for us as users. You have to stop saying, that didn't work. I know it's tempting, but if the agent goes down a wrong path, typing, no, do it the other way, just adds to the noise. The bad attempt stays right there in the context window, polluting the agent's reasoning. Instead, you've got to use the rewind command. This lets you surgically excise the bad trajectory entirely. You just roll the system back to before the mistake was made and drop that failure out of memory completely. And finally, Section 5. Mastering developer workflows. Moving from simply coding to orchestrating requires building some brand new habits. Your first new mantra needs to be plan first. You've got to rely on the plan command to force the agent to articulate its architectural approach before it modifies a single file. By separating design from execution, you get to act as the senior engineer reviewing an architecture document. Only once the plan looks rock solid do you let the execution harness take over and actually start manipulating files. Second, you need to rely heavily on validation loops. Look, Claude Code isn't some magical generator that gets it perfectly right on the first try. It's an iterative optimizer. The agent actually requires the objective feedback of deterministic tests, linters, and type checkers to iteratively correct its own work. If you provide a strong test suite, the agent is going to loop through reasoning, acting, and observing until those tests pass green. Third, steer actively. Don't just sit back and wait for the loading spinner to finish, because the agent interleaves reasoning and acting. If you see it starting to head down the wrong path, you've got to interrupt it immediately. Protecting your context window from irrelevant garbage is, hands down, your primary responsibility as the human supervisor here. Ultimately, your control plane lies in explicit orchestration hooks. The commands you type, like /clear, /compact, /plan, or /batch, they aren't just convenience shortcuts. They are explicit hooks that mutate the state of the execution harness. When you use /batch, for instance, you aren't just sending a prompt. You are literally decomposing parallel tasks and spawning independent subagents, each with their own clean context window. You are programming the harness itself. So I'll leave you with this final thought. Once you master orchestrating this powerful loop, where the harness does the acting, the tools touch the environment, and the model does the reasoning, what exactly is your job now? How will your daily role as a software developer fundamentally evolve when you move from being the one writing the syntax to the one designing the rules of the entire system? Thank you so much for joining me on this explainer. Keep learning, keep experimenting, and I'll see you in the next one.